So 3.4, properties of logarithmic functions. So these are our product rule, our quotient rule, and our power rule, which I gave you my little catchphrases for in your notes. So with a product rule, log of a product is equal to the sum of the logs. For the quotient rule, log of a quotient is equal to the difference of logs. And the power rule, throw it out front. So, number 2, the ln of 9y. These instructions say assume x and y are positive. Use properties of logarithms to write the expression as the sum or difference of logarithms or multiples of logarithms, depending on what it is. So, obviously, this is multiplying. So, this is going to turn into ln of 9 plus the ln of y. So this is what you would call expanding. I think we briefly got to touch on this last year. And so we just did like a little bit with it, and I pretty much told you to either expand the log or condense the log. So right now we're expanding. Normally I don't get that far in Algebra 2, so I don't remember. But anyways. 4. Log of 2 over y. So this is a quotient, so it splits to log of whatever the top value is minus the log of whatever the bottom value is. So log y.
Why do you remember this?
Just remember this whenever you want my.
I'm gonna briefly backtrack just momentarily to this previous problem. I would have stopped here. However, looking at the answer in your book, they go one step farther because they rewrite this as the ln of 3 squared plus the ln of y. And then they use the power rule to put it out front and do 2 ln of 3 plus the ln of y. It's not really necessary, in my opinion, to do this. I would leave it here where I stopped in blue. But I'm just showing you for the sake of if that happens as you're going through your homework and you're like, I'm pretty confident I did this right and you can't figure out why, it could be for some reason like this. If whatever value that's here is something that can be squared or cubed or whatever, it could be that they've done this. Not really necessary. Honestly, I think this is kind of a worse answer than this one since the ln of 9 is just a number. But anyways, I just want you to be aware of that. 6, log base 2 of x to the negative 2. So this one does have a power. Obviously, if the variable has a power on it, then we obviously need to use the power rule and put it out front. So we take that negative 2, stick it out front, and so I have negative 2 log base 2 of x.
Put me on Philly Whitney, I like this.
8 log of x times y cubed. So when I have one like this one, we can't take that y cubed, we can't take that cubed value and put it out front yet, okay, because it's not everything being cubed. If it was instead like this, then I would. But it's not, it's just on the one piece. So I'm going to split it first to the sum of the logs. Log x plus log y cubed. And then now I'll take that power and throw it out front. And so we have log of x plus 3 log of y. So that would be your final answer on that one. Now, if you feel like you can go straight from here to this answer by taking that power and going ahead and putting it in front, you're welcome to do that. Okay, I trust that you're know yourself well enough to, can I do that or should I do it in steps? It doesn't really matter to me. But I typically will do it in steps just so that I make sure I don't miss something that's going on there. 12, We got the ln of the cube root of x over the cube root of y. So what do I have going on here?
Subtraction.
Something I don't want to do.
Yeah. So the stuff's being cube rooted, and then also it's going to end up with, I have division, so I'm going to end up with subtraction. So we can kind of go about this two different ways. I would probably go ahead and split it as subtraction first. But one thing I do want to point out is that this can be rewritten as the ln of x to the 1/3 over y to the 1/3. And think about it this way instead, because that's going to make it powers, which is going to allow me to eventually throw it out front. And typically we don't want to have not that you can't have a square root and radical, but we would prefer to get rid of that. And so we would use our rules to do that and simplify it as much as possible. So this is going to become the ln of x to the 1/3 minus the ln of y to the 1/3. And then we'll put the 1/3 in the front. So 1/3 ln of x minus 1/3 ln of y. Is there anything else I can do to this?
Absolutely. Factor out
Probably.
1/3.
Take out a 1/3. So 1/3 times the ln of x minus the ln of y. Now, I think Daniel said something at the original moment when we were starting this problem about it's the cube root of the whole thing. If I had gone about it that way, I would have automatically seen that because, so let me go over here and read you this. So if I took my original problem and I rewrote it as the ln of x over y raised to the 1/3, aka I took the cube root of the whole thing, I would have thrown this out front to begin with and done 1/3 ln of x over y because the whole thing was in parentheses raised to the 1/3. And then at that point, I would go to 1/3 times the ln of x minus the ln of y that way, and you could have gone about it that way as well if you wanted to. Up to you. I usually do it the way that I did in blue, but if you see it and can do it this way, you can also do that. Just make sure you put the parentheses here because it's not just 1/3 ln of x. It's 1/3 times the ln of x minus the ln of y. Questions on those? Okay, so that's expanding the log. So that's when we're going from a single log to multiple logs. But we can also have the reverse where we're condensing the log down. And so it says assume x, y, and z are positive. Use properties of logs to write the expression as a single logarithm. So it's telling you like we're going to have one only. So we're just working in reverse now. So 14, we have log of x plus log of 5. So log of a product is equal to the sum of the logs. So if these were being added, then that means I'm going to be multiplying. So this is going to become the log of 5x.
Do these get harder?
They can, like, I'm looking to see because normally I think the ones in our Algebra 2 book were harder. They usually end up with a lot more things like that happen to them, but I don't even.
Right. Okay.
So yes, they can, but I don't see any that are. If that makes sense.
So our homework's gonna be easy.
Should be.
Yay.
This should be another super easy section.
I like this math.
Ran away.
I'm
16.
not taking math next year.
The ln of x minus the ln of y. Alright, so what would this one turn into if I'm trying to write it as a single log?
Oh, it's a log?
Well, these are logs. It's
L
just a
N
natural log.
I want to
X
pick a
Wait,
log.
ln isn't log. Wait, what is
It's
ln?
natural log.
ln is natural log.
So, log.
We're writing it as a single log. So we went
I
from
thought
2
those are
to
two
1.
completely different things.
I mean, log and ln are two different things, but they're both logs. One is just log base e and one's log base 10.
You said one is log base e?
This is technically, they just write it this way to shorten it. if it's log base e.
That's really just, look, there's,
What is on your hand?
you can see that?
I
Yes.
thought you were talking to me. I was like, is there something on my hand?
No.
And then I was like, can you see it?
Hey, you're painting with yellow.
Yeah.
Did you leave your palette in the sink? Because Desha was crashing out on us because she thought one of us did it.
18. 1/5 log of z.
I know this one. It's log z to the 1/5.
Yep.
Good job, Shepard. Thank you.
Log of
That's
z
also
to the
log base
1/5.
10 z to the 1/5. Wow.
Yep. I'm okay with you leaving it here, but I'm going to also let you know that the book may do this. Log of the 5th root of z.
That's where my brain.
Both are the exact same thing. I would take it either way.
Is ln base 10 log?
ln can't be base 10. ln is only log base e.
Oh.
It's a natural log.
Yes.
E is equal to like
Because we just did it with the 1/3
2.7.
thing. Back on
Right.
12.
2.717, yeah. Alright.
No way.
24 log of y minus log of z.
She was wrong. E is not equal to.
So what do I have to do with this one?
So first you,
Log y to the 4th over z.
Oh yeah.
Yep, so I would be moving this 4 up here. So if you want to do, like, just kind of draw an arrow so that you can see it. And then we would have log of y to the 4th over z, because it turns into division.
Syntax.
What does that even mean?
It's just like a domain error. Just syntax is just like your
having an
notation.
grammatical sentence. Like,
Now,
I said.
I hesitate to even say this, but a lot of people try to write the log on the top and the log on the bottom. That's not how condensing a log works. So make sure you always check that you only have one log written in your final answer when we are condensing it down into a single log. The instructions are pretty clear. You have a single log. But I'm just saying it because that's where this part isn't what gets people. It's that they write log too many times. So just make sure you are careful with that. All right, one more. Slightly harder one just because, why not? This is literally as hard as they get in this book. So just, 3 ln of x cubed y plus 2 ln of yz squared.
So they didn't
So-
take the cube and the square of those.
Yeah, I don't know how many this.
They did not. So, good question. They did not expand this all the way initially.
Yeah.
This was not fully expanded. So that's where we have to pay attention, though. We're not expanding, we're condensing. So I'm trying to smush this into one log. So essentially they just made my life easier because they didn't expand it all the way. Because yes, this would not have been fully expanded. So the first thing that I would do is I would take these things and I would move these up here to be their exponents. Because, so I'm going to move this and write this up here so I don't have to write the whole thing again. Because what's going to happen is now I need to cube both of these things in here to write this as a single, well, actually, well, I am going to ultimately have to do that. So I would go ahead and essentially distribute this through. So I would get the ln of x to the 9th y cubed plus the ln of y squared z to the 4th. Now we multiply these two things, so I have the ln of x to the 9th y cubed times y squared z to the 4th. Now I just need to combine the y's together in here because everything else,
Bless you.
I don't know what that was. Everything else is just an x, just a z. So my final answer is the ln of x to the 9th, y to the 5th, z to the 4th. Told you just had to suffer through a few months and then you get to the easy stuff.
This is the lowest my grade has ever been.
I haven't put in yesterday's quizzes yet. Well, I haven't
That's
graded
gonna
them,
get
so
worse.
hopefully they were good. But, okay. that's the last one of those ones. And then we've got change of base. So, Shepard should be a pro at this because he's had to change. No, because he's had to do change of base with. You literally just launched the batteries out of your calculator. Because when he had his older calculator, the only option for him to plug a log into his calculator was to use the change of base formula.
What's it? Wait.
I was telling him a story, he wasn't listening.
I could tell.
What's the change of base? There's a formula for that?
It's in your notes, isn't it?
Change of base.
Did you do your notes, Shepard?
Log b to the x equals log a x over log a b. X? I can't read it.
So, if it doesn't specify, and I'm going to tell you these ones do not specify what base you're changing it to, then we're going to change it to a common log, so log base 10. That's just going to be our general rule. Now, it does not matter. You could change it to log base 1000, and you're going to get the same thing. Really doesn't matter, just harder to plug into your calculator. The reason we're using common log is because there's a button for that on our calculator. So, yes. 24. Log base 5 of 19. So, we're writing this now as a common log. So, it's the log of the big number over the log of the little number. So, in this case, you do have the log written twice because it's a change of base formula. It's not condensing. What is happening?
I really do not know.
So we have the log of 19 over the log of 5. So you would, on your calculator, we would use our regular log buttons that are on here. So we would have log of 19 divided by log of 5, and we get an answer. Now, to prove to you that that's the exact same thing as if I plugged this into my calculator, I'll show you with log base. So if I did log base 5 of 19, it's equal to the exact same thing. So, Shepard, the way you had to type it in last year was this all the time, no matter what, because your calculator couldn't do this. Your calculator should now do this, though. Now,
Press math.
because you can just type this into your calculator if you know how to use the log base function, what I'm going to tell you is the work that has to be shown for this problem is showing this step of rewriting it with the change of base formula as the log of 19 over the log of 5. And that's equal to 1.83 rounded.
I got a huge nose.
All right, 26. Log base 12 of 259. So how would I write this using the change of base formula with a common log?
Log 259 over log 12.
Yep. And then you would just type that in and get your answer.
You shush.
So 2.24. Okay, so obviously on those ones, they just gave us numbers. That's something we can type in. If there's a variable in it and they want us to rewrite it, so like the next one, say, write the expression using only natural logs. So they didn't start you with natural logs. We need to rewrite it. Then I'm going to make a note here. Natural log. Then what I'm going to do is 30 log base 7 of x. So if I want to rewrite this using natural logs, I use the change of base formula, but instead, because it says natural logs, instead of it just being log of whatever, it's going to be ln of x over the ln of 7, because they specified to me which way I had to do this one. And there's nothing else I can do with this problem. It just has to stay here because it has variable in it. (32) Same instructions. Log base 5 of c minus d. They want it written as a natural log.
Oh, this is cool. I know this.
So ln of c minus d over ln of 5.
Would that also be ln of c divided by d over ln 5? Or no? Never mind, no, it's not.
No, because it's
Frick.
there's nothing else we can do with this one. All right, same instructions. However, they want us to use the common log. So that just means log base 10. So 34 log base 4 of x would be equal to what as a common log?
Log
Log X.
Log X over log 4.
Yep,
I'm so smart.
Ryan's got this under control.
That's so cool.
All right, last one. Log of 1/3, or sorry, log base 1/3 of x minus y. As a common log, what would that be?
That would be log
Log
x
1/3
minus y divided by log base 1/3.
Or could it be? Oh yeah, you're right.
Oh, not base 1/3. My fault.
Yep, and that would be all you have to do. Pretty easy.
Yes.
All right.
Use the
Make that square.
After you write down the problems.
Okay, yeah, you're right. I keep on forgetting.
All right. I don't really know how this breakdown ends up happening, but 1 through 35, every other odd. I don't know if it actually is going to end on 35 or not, because I kind of merged 2 different homework assignments together to do this. So, anyways, if it ends on 33, that's fine.
I want to see if I can do this.